morning and Assalamualaikum to my doctor, Dr. Nur Najwa, and my beloved classmate. Today, we from Group 1 will explain about Experiment 1. Our team members consist of me, Khaira Kibib Abdul Razak, Moses Zakilo, Lim Zayi, and Muhammad Izul Fahmi. Experiment 1. Determination of melting point using capillary tube method. The objective of the experiment is to determine the melting point of various organic compounds and to use this to identify unknowns. Introduction. The temperature at which a chemical transforms from a solid into a liquid is known as its melting point. This is a physical property that is frequently used to identify compounds or to determine the quality of the compound. The temperature at which a solid melts and transforms into a liquid is known as the melting point. The relationship between structure and properties can be seen in the relationship between the melting point, melting temperature, and the molecule structure. As a result, melting values for various substances typically vary. A pure, non-ionic, and crystalline organic compound usually has a sharp and characteristic melting point, usually 0.5 to 1 degree Celsius range. A mixture of a very small amounts of miscible impurities will produce the depression of the melting point and an increase in the melting point range. Consequently, the melting point of a compound is a criterion for purity as well as for identification. You can find out an organic solid's melting point by adding a tiny amount to a tiny capillary tube, attaching it to, attaching it to the temperature stamp in the middle of a heated bath, progressively heating the bath and noting the temperature at which melting begins and completes. Pure samples usually have sharp melting points. For example, 149.5 to 150 degrees Celsius or 189 to 190 degrees Celsius. Impure samples of the same compounds made at lower temperatures and over a wider range. For example, 145 to 148 degrees Celsius or 186 to 189 degrees Celsius. The melt The melting apparatus and the tilt tube setup are two frequently used techniques for melting point determination. The general method is to heat the sample indirectly by placing the prepared sample in a pack in glass capillary or on a glass cover slip, in or on a heated medium. There are other designs such as a Fisher-Jones apparatus. Important. Note that unlike boiling point, the melting point is relatively insensitive to pressure and no pressure correction needs to be made.
I will present reagent, apparatus, and the procedure. For the reagent is benzoic acid and salicylic acid. For the apparatus, glass capillary melting point tube, glass, petri dish, micro spatula, ruler, glove, wedging paper, mortar, and pestle. Next. Procedure 1. The solid must be dry or the result will be affected as solvent can act as an impurity and affect the melting range. If the solid is granular, the solid will pulverize it before packing. The capillary tube was inverted and the tube on the bench top was gently tapped to cause the solid to fall to the closed end. Then, drop the capillary tube closed side down several times through a long narrow tube. Second, the capillary tube will bounce as it hits the bench top. and the solid was packed into the bottom of the tube. Failure to pack the solid well may cause it to shrink when heating, which can cause confusion as to the correct melting temperature. If needed, repeat the previous step to load sample until it is a height of 2 until 3 millimeter in the tube. Third, it is important that the sample be no higher than 3 millimeter or the melting range will be artificially broad. Melting point apparatus. The first one, the capillary tube containing the sample was inserted into a slot behind the viewfinder of a melting point apparatus. There are usually 3 slots in each apparatus, and the multiple melting points can be taken simultaneously after gaining experience with the technique. Second, the apparatus was turned on and the setting was adjusted to an appropriate heating rate. The rate of heating is often experimental and should be as adjusted by careful monitoring of the thermometer on the apparatus. Third, look through the viewfinder to see a magnified view of the sample in the apparatus which should be eliminated. The fourth procedure is if the expected melting point of the compound was known, it was heated at a medium rate to 20 degrees Celsius below the expected melting point. Then the rate of heating was slowed down such that the temperature increases no more than 1 degree Celsius every 30 seconds. The temperature must be incremental as the melting point is approached to the system can reach equilibrium, making the thermometer temperature an accurate gauge of the solid's true temperature.
Now I will talk about the procedure for the experimental one. If the expected melting point of the compound was not known, the sample was heated at a medium rate the entire time and determine an approximate melting point. Process was repeated with a fresh sample after allowing the apparatus to tool and use the recommendation in Point 4 to perform a more careful assessment of the melting point. A fresh sample was necessary for a second melting point trial, even if the first sample solidified after cooling it should not be used again. Differences in crystal structure between the original solid and the previously melted solid could lead to different melting range. And next, a solid may be approaching its melting point if the solid was seen pulling away from the wall of the tube to form a cone of solid, which was called sintering. Melting will normally occur within a few degrees of this point. The solid may also shrink or compact before melting. First, temp- First temperature of the melting range with the appearance of a first visible rod of liquid was recorded. At first, it may seem as if a side of the solid glistened, and the temperature should be recorded when a droplet was seen on the side of bottom of the tube. Temperature reading was recorded to the nearest degree, although some thermometers may read to greater precision. The imperfect heat transfer between the metal board and the sample leaves the error larger than 0.1 degrees Celsius. The second temperature of the melting range was recorded when the entire sample has just melted, which occurs when all portion of the opaque solid has turned to a transparent liquid. If another melting point trial is to be performed directly after the first, The metal block should be rapidly cooled to at least 20 degrees Celsius below the next melting point by touching it with a wet paper towel or cooling it with a jet or air. So here, here are some photos during our experiment one, and this for the result for the benzoic acid, and this for the salicylic acid. And precaution step during the experiment one. First, always wear sensitive glasses in the lab. Avoid skin, eyes, and inhalation contact with all chemicals. Handle all chemicals with care. Never insert a room temperature thermometer in a hot melt temp. It may shatter. Do not heat the melt temp beyond the upper temperature of the thermometer. Do not leave the melt tent if it is not being used, and do not leave it on when unattended. The part on the top of the melt tent are hot while it is turned on. Do not touch the part or place your eyes on the eyepiece. You will get burned. Capillary tubes are cast. They break very easily, so handle them with caution. The following unusual situation may occur in the process. The sample may begin to darken, which indicates decomposition is occurring before the sample is melting. Take note of the decomposition temperature, as it is sometimes as reliable a reference point as a compound melting point. Use the letter D after a melting point to indicate decomposition. The sample may submit instead of melting. Sublimation may be noticed by a ring of solid above when the sample is heated. Take note of this behavior in your lab notebook.
Will explain about the result that we have got, we have obtained from the experiment of capillary tube method, and the result will be about salicylic acid and the benzoic acid. And in this result, we decide to just record for at for different temperature for each sample. And for salicylic acid, we have record the temperature from 157 degree until 160 degree, and at 157 until 158 degrees, the salicylic remain the state of solid, and then at 159 degree, we have observed that the salicylic start to melt, which is the solid to liquid. And then at 160 we have observed that the salicylic acid completely becomes the liquid. So we can say that the salicylic acid, the melting point of salicylic acid is at 159 degrees Celsius. Okay, move on to the benzoic acid. So from the table benzoic acid, we have record the result at 131 degrees Celsius until 134 degrees Celsius, and at 131 until 132 degrees Celsius, we have observed that the benzoic acid at the solid state, and at 133 degrees Celsius, the benzoic acid start melting uh, to liquid, and at 134 degrees Celsius, we have concluded that the benzoic acid completely becomes liquid. So the melting point for benzoic acid, which is 133 degrees Celsius. So the conclusion that we have come out from this experiment is through the experiment using capillary tube method. This method is able to determine the melting point of organic compounds such as benzoic acid and salicylic acid, which is we obtain that the benzoic acid melting point is 133 degrees Celsius and the salicylic acid melting point is 159 degrees Celsius.
Okay. And so for the question number one, define the melting point of a substance. The, the melting point of a substance is the temperature at which it changes one state from solid to liquid. At the melting point, the solid and liquid phase exist in equilibrium. The melting point of substance depends on pressure kilopascal in kilopascal.
Question number 2. What is the purpose of determining melting point? First, the melting point is a characteristic property of solid crystalline substances. It is the temperature at which the solid phase changes to the liquid. The purpose of determining melting point is to characterize solid crystalline materials. It is used in research and development as well as in quality control in various industry segments to identify solid crystalline crystalline substances and to check their purity.
And now I will talk about the question 3. Why is this method not used for finding the melting point of inorganic compound? Inorganic compounds are often ionic and so have very high melting point, while some inorganic compounds are solid with accessible melting point, and some are liquid with rational boiling point. They are not the exhaustive tabulation of melting or boiling point data for inorganic compound that exist for organic. So, in general, melting and boiling point are not useful in identifying an inorganic compound.
For the question number 4, which is why could the rate of heating influence the melting point? So the rate of heating is involved the temperature. So that when the temperature increases, the kinetic energy of the particle in the solid could be increased. So the occurrence of the collision between the particle will also increase. That leads to decrease in force of attraction between the particle of solid, and then the solid will start to melt.
So that's all from me. Good one for experiment one.